Hi, my presentation topic is exploration of 3D visualization for system optimization. This is my outline for my presentation. Um, my presentation will talk about my project for these courses, and first of all I will talk about the my original thought about the project, and then talk about the visualization for the iterative algorithm. I will check each iteration, it, how it progress in the function, uh, and then I will talk about the Canvas hub and its implementation. And the implementation I use a create hub function to organize the data into a Canvas hub. Finally, I will reach a conclusion. Uh, let's talk about my original thoughts. Um, at the very beginning, I tried to visualize high-dimensional data and functions on high-dimensional data to high-dimensional data. I found a paper. It introduced these graphs for visualization of high-dimensional data. It also used the color as one dimension. But I think the colors are not very useful because you are hard to find. If you want to find a specific color, you have to look you can search the whole graph or the whole picture to find a specific color. But typical graph you can locate easily. So overall, I think these graphs are not very intuitive because it takes time to understand it and it is explanation. Um, because we only have the knowledge for the 3D world. Um, so I began my project in the 3D three dimensional data. By the way, the screen is two dimension. No, but human can interpret it or interpret it easily because we have knowledge of the 3D worlds. Um, and then I will find the property of the high dimensional data and use some very common concepts like convexity to organize high dimensional data. Um, the tools and basic concept in my uh, in my project are the following. First of all, I will use the OpenGL 3D graphic API. It is a famous and old 3D graphic API, and C++, which is a programming language. And I will also use the knowledge of linear algebra and geometric computation to to do the key implementation for the abstract algorithm. Uh, I will visualize each iteration for minimizing function on two dimension to one dimension, and then I will implement the key algorithm. Uh, Minimizing with step-based gradient descent. This is the function I try to minimize. It's a testable algorithm, and I use the backtracking line search. You can look at the graph, and the step length is large and adjustable, and it use close to the optimal direction and step length. You can see the white line in here. Next, I would this is my other algorithms is called stochastic gradient descent. It's a popular algorithm in machine learning. This is the function I try to minimize. The step length it depends on the derivative of the derivative of the cost function. The step length is not large, but the direction is close to optimal. It's a simple algorithm. It's easy to implement. It randomly chooses a dimension to minimize. Or in fact, the direction is not close to minimal, but it randomly chooses a dimension to minimize. Then this is the simulating annealing. It's one of my favorite algorithms. It minimizes the sinc functions. It has multiple local minima. The simulating annealing algorithm can minimize function with multiple local minima because it chooses the random direction and random step. Theoretically speaking, it can find the global minimum, but practically it will take a long time to find the local minimum. And some practical disadvantage. It does not have terminate condition. Setting the temperature and setting the acceptance functions a difficult issue. You also have to consider the initial temperature and how the temperature decrease, and there also the scaling. Because at the beginning you don't know what the function is, and it's difficult to set it and know the scaling, what kind of scale you should use. It's a popular algorithm in the VLSI placement. So I have shown 3 examples to minimize function from 2 dimension to 1 dimension. I have visualized part of the function which contain the minimum. I use the sampler technique and sample the function and then interpret it with triangles, and then send the data of triangle to OpenGL, and the OpenGL will interpret the triangles. For the practical application, because you only can visualize part of it, but it's not practical to use this technique to find the minimum, but it's a tool to debug the algorithm and visualize the algorithm. Let's talk about the QHop algorithm. First of all, I will show you the overall algorithm and then explain it, and then I will talk about my key implementations. This is the QHop algorithm. A face in here is a triangle formed by 3 points. At the beginning, you have a set of high-dimensional data, and then you have to choose the extreme point to form the initial convex hull. After the convex hull is formed, you iterate through each face and then identify the outside points. If the point is above the face and is outside of the convex hull, and then you go into the big for loop. It also select the extreme points